Hello again, Year 10 triples. This is the second lesson in the series from your fact book, covering the second law of facts. Now, as you might have gathered from other videos, there is some overlap. So year 9s, if you open a video and it says year 10, and I say year 10 at the start, it doesn't mean you're on the wrong video. This video I'm doing now is the second set of facts for the triples. It's the third set of facts, or the video for the third lesson for the year 10 core, and it is the fourth video for the year 9. So it's the video accompanying lesson 4 and the fourth set of facts for year 9. So it's looking at group 1 and group 7 elements. Hope that makes sense. If you look in your fact books, you should be able to match it up. We're going to start just with some questions on a couple of the bits we've covered, you've all covered by now. So there are 5 questions now. You can pause it and have a go at answering them, and I will give you the answers just in a second. Okay, so question number 1 says, what did Mendeleev leave in his version of the periodic table? What he did was he left gaps for elements that had not been discovered yet. So he didn't just rank the ones that we'd found, he left gaps in his periodic table so that elements that had yet to be discovered could fit in those gaps. Question 2, what was Mendeleev able to do that proved that his system worked? Well, what he was able to do was, based on the elements that were in the table, he could make predictions about the ones that would fit in the gaps. And then when those elements were subsequently discovered, their properties were very close to the predictions that he had made. Number 3, what model of the atom did J.J. Thomson come up with? J.J. Thomson came up with the plum pudding model of the atom, where the atom was a positive structure with random negative charges spread through it. Number 4, which scientist discovered that electrons orbit the nucleus in shells? That was Bohr, B-O-H-R. And number 5, what metal foil did Rutherford use in his experiment? He used gold foil. They talk about the gold foil experiment. So hopefully you've done okay in those, and you're retaining or revising some of the stuff we've been doing. Hopefully you are all still safe and well, obviously, and doing okay. Right. Moving on to today, we are going to start with the group 1 elements in the periodic table. You will already have labelled them and you will have it in your books and everything else. But the group 1 elements is the first column on the left hand side of the periodic table. It is the elements on the screen: lithium, sodium, potassium, rubidium, cesium and francium. Okay, in the first column of the periodic table. Okay, they are known as the alkali metals. And there are certain things you need to know about those, as you will see in your fact book. So the characteristics of the alkali metals: they are soft, they can be cut with a knife. Okay, you have seen these in class, all your groups, year 9 and 10, you will have seen these possibly more than once. They can be cut with a knife or a scalpel, as you will have been shown. As you go down the group, the softness increases. So the metals lower down in the group can be cut more easily than those higher up. They have a low density, which means they float on water, which is unusual for metals. Metals generally have high densities. And they have low melting and boiling points. Okay, they do share some properties of metals with other metals. They are good conductors of heat and electricity. They are also shiny when you first cut them. But because they are reactive metals, they don't stay shiny for very long. You probably remember from class that they are stored in oil to avoid them reacting with oxygen and water. So those are some of the key points that you need to be aware of for the alkali metals, the group 1 metals. They react vigorously with water. You will remember these experiments. Your teacher would have got a big trough of water, put it behind a safety screen, and put very small amounts of certainly sodium and potassium to show you the reaction. And they react very vigorously, they produce a lot of gas, they fizz around on top of the water. Potassium even catches fire with a lilac coloured flame. Now it says there the reaction produces a gas that ignites a lighted splint with a squeaky pop. Hopefully you remember from other lessons the squeaky pop. If you burn a gas and it burns with a squeaky pop, that shows you that it is hydrogen gas. The green universal indicator, if you add that to the water before you react the metal with the water, it turns purple. That tells you the product, one of the products of the reaction, is an alkaline substance. So you have hydrogen gas and an alkaline substance, which is a metal hydroxide. Okay, so that is the group 1 metals. The facts you need to be aware of: they are soft, they can be cut with a knife, they are shiny when they're cut, they have low melting and boiling points, they have a low density, which means they float on water, and as you go down the group, they get more reactive. So sodium is more reactive than lithium, potassium is more reactive than sodium, and so on. And that's because as you go down the group, the atoms get larger, there are more electron shells. That means the outer shell electron in each case gets further away from the nucleus. Now if it's further away from the nucleus, that means it's less attracted to the nucleus, because there's more distance between the positive nucleus and that electron, and that means it can be lost more easily in reactions, which means as you go down the group, that outer electron gets further away from the nucleus, so the nucleus holds on to it, for want of a more scientific expression, with less force, and that means it can be lost more easily. So when potassium reacts with something, that outer electron is lost more easily because it's further away from the positive attraction of the nucleus. Okay. So as you go down the group, the reactivity of the alkali metals increases. So make sure you learn those 4 facts. Group 7 elements, the halogens, well, they are in the 7th column, going from left to right across the periodic table. You can see them on the screen now. They are fluorine at the top, chlorine, bromine, iodine, and astatine, in that order, top to bottom. So they are the group 7 elements. They are known as the halogens, or halogens, and there are certain things you also need to know about those, as you will see from your fact book. Okay, so halogens are very reactive non-metals. They are all toxic or harmful because they are so reactive, and so they have been used for things like antiseptics, because they kill bacteria and other living organisms. It's also why we use chlorine in swimming pools in very measured amounts to make sure the water stays clean, or certainly clean enough for people to swim in. Okay, you don't find the halogens in nature free as pure elements because they are so reactive, but you generally find them as compounds. Okay, and that's where the name halogen comes from, because they form salts with metals so easily. Halogen means salt former. Okay, none of these are on the fact book, but that's just a bit of background. Okay, so all the halogens have 7 electrons in their outer shell, hence they are in group 7 of the periodic table. That means they react easily because they only need to gain 1 electron to fill their outer shell. Because they gain 1 electron, they form ions with a negative charge of -1, and they all have similar chemical properties because they all have 7 electrons in their outer shell. Okay, the properties of the halogens you need to be aware of. These are the things in the fact book you need to make sure you're clear on. All the halogens are non-metals, so they do not conduct electricity. When they are solid at certain temperatures, they are brittle and crumbly, and they are also poisonous or toxic, and generally, when they have become a gas, they have a very unpleasant smell. As you will see in the fact book, you also need to know some of the visual properties. Fluorine is a pale yellow gas at room temperature. Chlorine is a green-yellow gas at room temperature. Bromine is a dark orange liquid at room temperature. And iodine is a grey solid at room temperature. Now the reason they are not all in the same state at room temperature is because the boiling points and melting points also change as you move down the group. So as you go down the group, they become darker in colour, from pale yellow fluorine at the top, green chlorine, dark orange bromine, grey iodine. But also as you go down the group, the melting points and boiling points change. Okay, so fluorine melts at minus 220 degrees centigrade and it boils at minus 118 degrees centigrade. That means at room temperature, fluorine has already boiled, so it is a yellow gas. Chlorine boils at minus 101 degrees centigrade. Melts at minus 101 degrees centigrade. It boils at minus 34 degrees centigrade. So by room temperature, which is about 20 degrees, it has already boiled, hence it is a green gas. Bromine does not boil until 59 degrees. So at room temperature, around about 20 degrees, bromine has still not boiled. It has melted but not boiled. So at room temperature it's a liquid, dark red-orange liquid. And iodine doesn't melt until well over 100 degrees and it doesn't boil till almost 200 degrees. So at room temperature, iodine is still a solid. Okay. So if you want to pause it and make a note of those properties as well, by all means do so. So, key points on the group 1 elements are they're soft. The group 1 alkali metals are soft. They float on water because they have a low density. They are shiny when cut, and they have a low boiling point. They also get more reactive as you go down the group. Group 7 elements, which we've just spoken about, the halogens, get less reactive as you go down the group. As you go down the group, their boiling points increase. And you also need to know some of the properties. They are non-metals. When they are a solid, they are brittle and crumbly. And fluorine is a yellow gas at room temperature, chlorine is a green gas at room temperature, bromine is a red-orange liquid at room temperature, iodine is a grey solid at room temperature. So make sure you're clear on those facts in the fact book for this lesson, these key points on the group 1 and group 7 elements that I've just gone through. Hopefully that's been of some help, hopefully that has rung a bell, because as I said previously, this is revision that we're doing from earlier in the year. So thank you.